hopefully that looks like a 1b. I'm in chapter 2, 1b. The system of equations. Now I have two equations. These variables are not x, y, and z, but x1, x2, and x3. So there's three variables. Okay, so I want to say that that system of equations is equivalent to something. I am supposed to put this in an augmented matrix form. I know how to do that all in one fell swoop, but this time, how about if I say that that system of equations is equivalent to something else? But you know what, since I'm making reference to the whole system, that's why I put a bracket right there to collect together the two equations into one object, right? When I say is equivalent to, I mean this system is equivalent to. And again, that symbol is just shorthand for the words is equivalent to. And now what I'm going to do is I'm going to have a 2 vector whose first component is this stuff. Let's see. Negative 4x1 plus 5x2 plus 8x3. So that's just going to be the first component of what's here. I'm going to have a single equal sign, and the first component of the thing on the right side of the equal sign is going to be 3, and then the second component is going to be 7 to go with that. Okay, so negative x1 plus 3x2 minus 6 x3. And this typo was brought to you by too much coffee today. That plus sign somehow fell over. Let me try to bring him back. There we go. I've revived my plus sign. Okay. This system of equations is equivalent to the single equation between two vectors, and all the variables appear on the left side. Now that, in turn, is equivalent to, this is what we usually denote by a matrix, right? This is the algebraic expression form of a function that we also denote by a matrix. We denote it by the matrix negative 4, and then 5, and then 8. Negative 1 goes with x1 down there, negative 1, 3, and negative 6. And that algebraic expression right there is obtained by putting in x1, x2, x3, of course, in that order, so that the x1 gets paired up with the negative 4, the x2 with the 5, and the x3 with the 8, etc. And on the other side, we still have 3, 7. And that, in turn, is equivalent to an expression that's even more compact, where we simply leave out the variables, the 3 vector with the variables in it, and the equal sign, and collect in all of the relevant numbers into some very minimal notation. An augmented matrix. Negative 1, 3, negative 6, and 7. Okay, now that was a sentence because the system of equations is equivalent to, which is equivalent to, right? So this right here is a pair of statements joined together with an and. This statement and this statement simultaneously is equivalent to this single statement, which is equivalent to this single statement, which is equivalent to what this augmented matrix encodes.